Okay, we're going to do our first lesson today on factoring. So far, we've done multiplication and distribution of polynomials. And when we do the double distribution, sometimes we call that foiling. Factoring is just the opposite of that, or undoing that multiplication. So distribution is like multiplication, where factoring is like division. If we were doing it with numbers, obviously multiplication is pretty simple. 7 times 5 would be something like 35. But if we were factoring, we'd start with the number 35, and you probably remember this from middle school. We'd make this thing called a factor tree, and we would put in two factors here that multiply to 35, like 5 and 7. So it's going the opposite direction of what multiplication did. The simplest form of factoring is pulling out what's called a GCF, the greatest common factor. Greatest common factor. When we pull out a GCF, what we're really doing is saying this is a factor that's common to every term, and we're dividing each term by it. So, for example, if I look at this polynomial here, this is a quadratic because of the 2, but this is a binomial, and we've named these by the number of terms before. So this is a binomial. We should notice that both of these terms, that term and that term, have a common factor of 3. Common factor of 3 in them. So we're going to pull a 3 out. When we do that, we put the 3 in front of a parentheses. A parentheses is large enough to hold the number of factors that we see there. So I'm going to have to fit 2 factors with that minus sign between them. When I pull a 3 out, I'm dividing each of those terms by 3. When I divide this term by 3, I get just x squared. And when I divide this term by 3, I get 3. So pulling a GCF out is the opposite of distribution. We can check our answer by thinking to ourselves, if I distributed this 3, would I end up with my original problem? Which I would. I'd get 3x squared minus 9. So pulling a GCF out is the opposite of distribution when we have a single number or a single term out in front of a parentheses. If we look at the next one, we have 1, 2, 3 terms. Remember, terms are separated by the addition and subtraction. I see a common factor numerically of 4 because 4 goes into all 4 of those numbers, 4, 8, and 16. When it comes to the variables there, we can get an x squared into all 3 of those variables. Okay, so we need to be thinking about what variable can go into each, what variable part can go into each of these things, and it's an x squared in this case. So if I put a 4x squared out in front of my parentheses, you gotta leave enough room to leave to fit a trinomial there because there's those 3 terms. The first thing we're going to focus on is that first term right there. Okay, what would I have to multiply this 4x squared by to get that 4x to the 4th? Well, I'd need to multiply it by x squared. So when I pull it out, it's the opposite of multiplying it back in. So I can just check it by mentally going, if I multiplied this by this, would I get the 4x to the 4th? Yes, I would. Okay, now we want to divide this negative 8x cubed by the 4x squared. So it's going to be a negative, and I'm going to need a 2x right there. Because if I multiplied this to this, I would get that 8x cubed, or the negative 8x cubed. Now I'm going to divide the 16x squared by the 4x squared. Or in other words, what would I need to multiply the 4x squared by to get this 16x squared? Well, I'd have to multiply it by just a 4. Okay? Whenever you pull a GCF out, just mentally check your work by going, if I multiply this guy back in, would I get the original? If I multiplied this in here like this, would I get that original? 4x squared times x squared is 4x to the 4th. Check. 4x squared times negative 2x, that's negative 8x cubed. Check. And 4x squared times 4 is 16x squared, so looks good. That's the simplest form of factoring. That's pulling a GCF out. Now, you're going to see more of this actually on your homework tomorrow. This is on the 6.4 B worksheet. You're going to see a lot of this GCF type stuff along with other factoring after you pull the GCF out. What we have down here is us checking that work. I talked about it already, but now you can write down here, if I distributed that 3 into that x squared minus 3, we could verify that we do get the 3x squared minus 9. So it's just you checking your work. And if I multiply that 4x squared into that x squared minus 2x plus 4, okay, if I multiply that in there, and there, I would get 4x to the 4th, because remember you add your exponents, minus 8x cubed, and then plus 16x squared when I multiply that 4x squared in. So check, that did work out. That gave us the original problem. Now the answer to this problem, if it asks you to factor it, is what we have written right here. We were just checking our answers by multiplying it back in. All right, now we're going to talk about factoring a trinomial of the form ax, actually let's do this, x squared plus bx plus c. And what we're going to do is, you can kind of tell there's this value a that is missing right there. That's because we're going to say a is 1. So the important part here is that we just start with an x squared, or maybe an m squared, or y squared, but just a variable squared. Okay, that's what we're talking about here. Now, we're going to look back at our distribution here to get us going. If we were going to multiply something like x plus 5 times x plus 2 together, I just want you to think about where the first and the last terms come from. The first and last terms come from multiplying the x times the x, which gives us x squared, and then the 5 times the 2, which gives us the 10. That's where the first and the last terms come from. Okay, the middle stuff, which we end up combining, comes from multiplying the x times the 2, which gives us 2x, and the 5 times x, which gives us 5x. And then we end up simplifying that to x squared, and then the 2x and 5x give us 7x. That's where the simplifying comes in, plus 10. So when we multiplied these two terms together here and these two terms together here, that gave us the two things that we could combine. Okay. Also notice when we multiplied those two values together, the 5 and the 2, that gave us that ending number 10. So what I have here is, notice that 2 plus 5 gives us the 7 that's in the middle, and that the 2, this should be times, 2 times 5 gives the 10, which is the c value at the end. Now we're going to talk about what happens when our signs change here. So if we were to distribute all these out here, we would have x squared, and then we would have, so that's to that, and then we'd have negative 2x and positive 5x. So again, I'm combining those two terms in the middle, but it's not going to give us the 7x that it did before because they both were positive. Now it's going to give us just a 3x. And then the last thing we have here is 5 times negative 2, which is negative 10, which I'm going to bring down there. So the negative 10 came from multiplying these together. Well, notice that when you multiply a positive times a negative, it's going to give you a negative right there. It's kind of something to keep in mind. So the fact that there was a negative 10 at the end kind of signifies that they must be different signs on the inside. We're going to have a negative 10 at the end of this one too, but this time our positive negative switch. So we're going to have x squared, and we're going to have 2x, and this time we're going to have negative 5x, and then that negative 5 times 2 gives us negative 10 again. So now one's negative, one's positive, gives us a negative at the end. But now when we combine these together, the 2x and the negative 5x give us negative 3x instead of the positive 3x that we had before. And that's because this time it was the 5 that was negative and not the 2. The last one, they're both negative. So when we multiply this out, we get x squared minus 2x minus 7x. But now notice what happens here. The negative 5 times the negative 2 gives us a positive 10. So the fact that they're both negative will make that a positive at the end there. In other words, when these two signs are the same, this is going to be a positive at the end there, whether they're both positive or both negative. So how do you know what they are? Well, notice when we had these two things together, the negative 2x, negative 7x, we get a negative 9x plus 10. Well, since those two numbers are adding up to give us this value right here, we know they both must be negative because they add to a negative 9, but they multiply to a positive 10. All right, if you don't see the patterns yet, hopefully going through these next three examples will help. Otherwise, go ahead and rewind the video and take a listen to what we just went through. Okay, I would take a look at these first three examples first. So here's the basic idea to what we want to be doing here. We want to factor this into two binomials. Okay, we want to find out what two binomials multiply together to give us this thing here. All right. Think about where that x squared comes from. That comes from multiplying this guy to that guy. So I know they both have to be x's. X times x gives us x squared. Now, the next thing I'd like you to look at is that negative 30. That's pretty much the most important value here because we want factors of negative 30. Okay, we want factors of negative 30. Okay, so I'm going to think of things like, and I'm going to put them in pairs. So like 1 and 30, except one would have to be positive, one would have to be negative. 2 and 15, 3 and 10, 5 and 6, that sort of thing. Okay, we need to put those factor pairs here because that's how we get that negative 30 at the end. We multiply those together. Okay, but here's the key thing: when we put those there, this product and this product, we need to make sure add together to give us the negative 7. Okay, confused? Well, watch what happens right now. The negative 30 has all these different factor pairs. I'm sorry about that we could choose from. But only one of them is going to work. Okay, if one works at all. If we put, for example, the 1 and the 30 in, 1 and 30, okay, 1 and x is x, x and 30 is 30x, and even if I made one of those positive, one of those negative, there's no way they're going to add up to give us negative 7x. Okay, so let's try this again. All right, so I'm looking for factors of 30 here that add to that negative 7 that's in the middle. All right, we want factors of negative 30. We want to find the ones that add to 7, which add to negative 7. Okay, and remember, one of these numbers is negative in those pairs there. Okay, so let's try. I don't think 2 and 15 is going to help us here. However, look at the 3 and the 10. They differ by 7. That's kind of your key thing right there. The 10 and the 3 differ by 7. So if you put the 10 and the 3 inside here, and it does not matter what order you put them in, but what matters, remember, is they have to add up to, going a little faster. They have to add up, the 10 and the 3 is what we want in there. They have to add up to this negative 7. Okay, well, if I have a 3 and a 10, how do I get those to add up to negative 7? Well, I make the 3 positive, and I make the 10 negative. And now look at it. I have 3x here, and I have negative 10x here, and when I add those up, they add to negative 7. So we kind of check it by doing these double products here, the middle product and the outside product. It kind of looks like a smiley face when you're done there. So you can be happy about the good factoring job that you did. Okay, there's our smiley face there. See it? Good. All right, so that's our answer. Okay, it's kind of messy looking because we were kind of doing all this check with the things underneath there. So I'm just going to rewrite it. X plus 3, x minus 10. That's our answer right there. Those two factors would multiply to give us that there. Okay, FOIL it out if you want to. Check your answer. You got x times x, that's x squared, negative 10x, and then 3x, and then negative 30. And look at those add up to that negative 7 that we had. Okay, but we pretty much did that by doing that guy right there. All right, let's take a look at the next one. Start with two binomials. We know that since we need our first two terms multiplied to x squared, it's got to be x and x. Okay, now we need factors of 9. Okay, so we got 1 and 9, maybe 3 and 3. That's about it. How can we get negative 6 from those? Well, I'm thinking 3 and 3 is where we want to go. But remember, they have to add up to negative 6 and multiply to positive 9. So we're going to have to go with negative 3 and negative 3 here. Okay, that would give us a negative 3x here and a negative 3x here. That adds up to the negative 6x. So we've got x minus 3, x minus 3. And at any point, if you need to, pause and rewind this video. Go back to some of the stuff that we talked about earlier to help you out and walk back through it again. All right, last one here. Now this one, notice the big difference here. Now we've got this other y squared here. So think about where that's going to affect our binomials here. Okay, I got my two binomials. This is still going to be x and x right here. There's no change in that at all. I want factors of 20 to go here and here, but there's also a y squared. So I'm going to have to put a y and a y right there. Now, that is going to be okay because our middle term has an xy in it. So when we do our multiplying out, both of those middle terms are going to have xy then, which is good. So what are our factors of 20? We've got 1 and 20, 2 and 10, and 4 and 5. And I need them to somehow give me 12. Okay, I think when you break it down like that, it's pretty obvious. 2 and 10 is where we want to go. So we're going to have plus 2y and plus 10y. I'm just going to do a quick check here with my little rainbows underneath here. 2xy, and then we've got 10xy. And if I add those together, it gives me the 12xy right there. So we just basically checked by foiling it out, kind of a quick way. So that's our answer. I'm going to go ahead and write it again. X plus 2y, x plus 10y. Those are our two factors right there. So we're going to take a step up here. We're going to talk about factoring trinomials of the form ax squared plus bx plus y, or excuse me, plus bx plus c. But this time, we're going to say a is not 1 anymore. Okay? So a little bit of a step up. The method that we're going to use is called guessing and checking. And I have a second method down here called the AC method. And we're actually going to skip this. Okay? I may do a second video where I go over that. This is kind of an optional thing. Look at, they're the same 4 problems as up above. I'm going to show you one method. If you want a second method to use or to try, you can watch the other video I make or come in and get some help. But for right now, let's skip that AC method and let's just talk about guessing and checking here. So we've got this trinomial, 5y squared, 11y, and 6. Let's put our two binomials, okay? And sometimes it might be a good idea to put like multiple binomials here because you're going to try a couple things out, hence the guessing and checking thing. The reason why I got to try a few things out is because now we can't just put a y and a y here. We are either going to have a 5y and a y, and well, that's it. That's pretty much all we're going to have there. So I'm just going to stick with one binomial right now because there's no other factors of 5 besides 1 and 5. No other factor pairs. Now 6, we could go 1 and 6, or we could go 2 and 3. Okay? So in these spots here, you need to think, do you want to put, and I wouldn't write this down right away because I might erase some of this stuff. Do you want a 6 here and a 1 here? Well, as you're kind of thinking about that, think about how you're multiplying these out. That gives me y. That gives me 30y. That does not add up to 11y. Okay? But actually, as I look at it, if I flip those two guys around, maybe that's what we want, right, in order to add up to that 11. If I put the 1 there and the 6 there, that gives me 6y. That gives me 5y. There, that adds up to 11y. That must be what our factors are. I didn't even have to go through the 2 and the 3. Okay? If I would have started with the 2 and the 3, I would have started with the 5y and the y, okay, and then just tried the 2 and the 3. 2, 3, and said, well, 2y and 15y, that's not going to work. Or maybe 3y 10y, that adds up to 13y. So that's not 11y. That's not going to work. So that's where the guessing and checking comes in. That's not what we want there. This is our answer right here. 5y plus 6, y plus 1. All right, our next problem here. We're going to start with a 3n and an n, because those are the only two things that can give us 3n squared. So it's kind of nice in that, even though we have a number here, if that's a prime number, that's nice, because there's really not a whole lot we need to do except put n and 3n here. Okay. Negative 1. There's really only one factor pair that works for negative 1. 1 and negative 1. Okay, so now we just got to think, do I want the negative 1 here and the positive 1 here? Or do I want the positive 1 there and the negative 1 there? Okay, so let's go through, because these multiply to give us, both pairs multiply to give us that negative 1. But it's which order do we want them in? Okay, so let's check by doing our multiplication here. We have n and we have negative 3n there. So those add up to negative 2n. That's not what we want. We have negative n here, and we have a positive 3n right here. Those add up to the positive 2n, and that's what we want in the middle right there. All right, so let's go ahead, erase some of this stuff that we got going on here. I'm just going to erase that, and there we go. Now, what's bad with erasing everything I just did is there's really no way to tell what process we went through. If this was all you had left on your work on a quiz, I'd be okay at that. Maybe you want to do some of the work off to the side and write your final thing there. But once you get used to doing these, they go pretty quick, especially when prime numbers are involved. All right, 2 more left here. Again, we've got some more prime numbers. This is pretty nice. There's nothing that we could put in the first 2 spots except for these 2 terms, a 5u and a u. Those are the only things that we can multiply together to give us 5u squared. The only things we can multiply together to give us negative 1 are a 1 and a negative 1. Okay? Oops. A 1 and a negative 1. So, again, it's thinking about, I want a negative 4. So let's be a little proactive here. I know I want the negative 4. I probably want to multiply the 5u a little bit smaller. I probably want to multiply that then by the negative value, minus 1. And I probably want to multiply the u by the positive value, because that would give me u and negative 5u, which adds up to the negative 4u right there. So that's our final answer there. 5u plus 1, u minus 1. Okay, one more. Again, we've got a prime number for our a values, so that's nice. We've got 2r, and we've got r. And now we're going to put factors of negative 3 in this spot and this spot. So 1, negative 3, negative 1, and positive 3. Okay, but look at what we want here. We want positive 5. Okay, so I'm thinking 3 and 1, because that gives me 6, and that gives me 1, okay? But I want it to be a positive 5, so I probably want the 6 to be positive, which means I want that to be positive. And I want that 1 to be negative, which means I need that to be negative, because those would then add up to that 5 that we have up there. So this is going to be our final answer, 2r minus 1, r plus 3. And that is the basics of factoring a quadratic trinomial.